Hello, this is Jessica Lopez, and today I will be talking about learning outcome 7.3, bone development and growth in section 4. Okay, so the growth of the bone. Long bones continue to lengthen potentially until adolescence through the addition of bone tissue at the epiphyseal plate. They also increase in width through apposition of growth. In the lengthening of the long bones, um, long bones stop growing at around the age of 18 in females and the age of 21 in males in a process called epiphyseal plate closure. During this process, cartilage cells stop dividing and all of the cartilage is replaced by bone. The epiphyseal plate fades, leaving a structure called the epiphyseal line or epiphyseal remnant at the epiphysis and diaphysis fuse. So now I'm going to talk about endochondral ossification. That is the process of bone development from hyaline cartilage. All of the bones of the body except for the flat bones of the skull, mandible, and clavicles are formed through endochondral ossification. So bones finish growing typically on growth at when they reach their maximum height between ages 14 and 16, and boys finish the growth of the bones between 16 and 18 years of age. Okay. In long bones, chondrocytes form a template of hyaline cartilage. Okay, so long bones lengthen as chondrocytes and divide and secrete hyaline cartilage. Osteoblasts replace cartilage with bone. A positional growth is the increase in the diameter of bones by the addition of bone tissue at the surface of bones. In the diagram to the left, you can see how the bone grow. Um, Endochondral ossification is the process of bone development from hyaline cartilage, and the periosteum is the connective tissue on the outside of bone that acts as the interface between bone, blood vessels, tendons, and ligaments. Okay, now I'm going to talk about intramembranous bone and endochondral bones and how they grow. Okay, so in intramembranous ossification, bone develops directly from sheets of mesenchymal connective tissue, and the difference between intramembranous and endochondral is that in endochondral ossification, bone develops by replacing hyaline cartilage. So in intramembranous ossification, the bone develops differently from endochondral ossification. So that's the difference between both of the bones. Okay, so now I'm going to talk about how they grow. So, activity in the epiphyseal plate enables bones to grow in length, and then modeling allows bones to grow in diameter. That's how both of them grow, and they grow by activity in the epiphyseal plate. And to the left, you can see the difference between intramembranous versus endochondral bones. So in intramembranous ossification, you can see that it's in the purple, which is the cranial vault, the maxilla, mandible, the clavicle, and in endochondral ossification is the skull base, vertebra, lung bones, and the pelvis. Okay, and lastly, this is my works cited. Thank you.